Have you ever wondered why your wireless devices sometimes seem to struggle more during a heat wave or a bitter cold snap, even when nothing else has changed? It is a common experience that points to a fascinating interplay between the physical world and invisible radio waves. Extreme temperatures absolutely impact radio frequency signal strength, primarily by influencing the atmospheric conditions and the physical properties of transmission mediums and electronic components. Both very high and very low temperatures can cause signal degradation, leading to reduced range, lower data rates, and increased errors. The core reason lies in how temperature affects the atmosphere and materials. In extreme heat, air density decreases, which can slightly alter the refractive index of the atmosphere, leading to subtle changes in how radio waves propagate. More significantly, heat increases the thermal noise within electronic components like transceivers and amplifiers. This elevated noise floor can mask the weaker incoming radio signals, effectively reducing the signal-to-noise ratio. Conversely, in extreme cold, while thermal noise is reduced, materials can become brittle, and moisture in the air can turn into ice, causing attenuation, especially at higher frequencies. Also, the impedance of antennas and cables can shift, creating mismatches that reflected some of the signal instead of transmitting it efficiently. For practical applications, this means that network engineers must carefully consider the operating environment when designing and deploying wireless infrastructure. For instance, in regions with vast temperature swings, equipment must be rated for extended temperature ranges, and network link budgets need to include sufficient margin to account for these environmental variations. Engineers might also employ techniques like adaptive modulation and coding schemes that can dynamically adjust to changing signal conditions, optimizing performance even when the environment is less than ideal. One interesting detail in professional wireless deployments is the concept of a fading margin. This is an extra allowance in the signal budget, often measured in decibels, specifically to compensate for unpredictable signal losses due to factors like temperature extremes, rain, or humidity. This buffer ensures that a link remains stable and performs reliably even under adverse environmental conditions. Without it, a wireless link might meet its nominal requirements on a perfect day but fail under stress. Understanding the influence of extreme temperatures on radio frequency signal strength helps us appreciate the robustness required for wireless network design. By accounting for these environmental factors through proper equipment selection, careful link budgeting, and dynamic adaptation, engineers ensure that our wireless connectivity remains reliable and consistent, even when nature throws its toughest challenges our way.
If you love understanding how the web works, like, subscribe, and stay connected with us.